Actually, there we go.
Yeah, it's under more. If you go under more, there it is. Perfect. Okay. Okay, so we'll get started then. Welcome everybody to Ashley's master's thesis. I have the honor of knowing Ashley since she was an undergrad in environmental studies and the water science emphasis. She was one of the students who just became fascinated with water, and then she went on to AmeriCorp and worked on water quality issues, and then came back for a master's degree. And I think that I know she's going to do an amazing job today with this presentation and talking about our watershed that we live in. I mean, one of the things with this project is being able to understand where we live and where we are at here in Northern Illinois University. If you have any questions, feel free to put them in the chat, or after the public part of this, we'll open it up to questions to anybody. Or as you're thinking of something, you can throw it into the chat right away. We'll do them at the end. Otherwise, I will give the floor on over to Ashley. So take it away.
Awesome. Thank you so much for that introduction. So the title of my talk today is going to be the influence of land use, precipitation, and seasonality on surface water quality in the east and south branches of the Kishwaukee River watershed. Frequently in the presentation, you'll see me use the acronym ESBKR. That just means east and upper south branches of the Kishwaukee River watershed. So going into some broad scale, just to start out, both urban and agricultural land uses have been linked to deterioration of surface water quality. In urban areas, there's an increased amount of impervious surface coverage and motor vehicle usage. And this can lead to higher chloride inputs from road salt. Now, there's this idea called legacy chloride, where after application of road salt, it doesn't just leave the watershed. It stays trapped in the soils for up to 30 years after application. The problem with this is when we have periods of heavier rainfalls, that chloride that's stuck in the soil can then leach out as surface runoff into our surface waters. There have been studies showing that this is already occurring in the Chicagoland area. Additionally, in urban areas, we're seeing increased population density has higher strains on wastewater treatment plants. And in return, this means that it increases the amount of wastewater effluent that is produced and then discharged into streams. In predominantly agricultural watersheds, we're seeing that the fertilizer inputs can lead to a nutrient enrichment or a eutrophication of streams. And this is a problem because it encourages the formation of harmful algal blooms. These blooms deplete oxygen levels, and they also introduce toxins that are hazardous to both wildlife and people. And it diminishes the recreational ability of the stream. And in some severe cases, these harmful algal blooms can create what are known as hypoxic zones, which are areas where there isn't enough oxygen to meet that of the biological demand. One of the largest dead zones is in the Gulf of Mexico, and studies have shown that nutrient inputs from the Midwest are largely responsible for that dead zone, even though we're thousands of miles away. When it comes to mixed watersheds, there is less known on the influence, and this is because mixed watersheds have varying concentrations of land use, as well as a diverse amount of activities that occur within the watershed. So when we're trying to determine which land use has the dominant influence in a mixed watershed, we really have to look at the watershed locally rather than applying this broad scale knowledge of what urban land uses do and what agricultural land uses do. Which leads us to our project. So this project was funded by DeKalb Community Foundation and DeKalb County Watersheds because they wanted to create baseline surface water quality data for the east and south branches of the Kishwaukee River watershed. And so my research question while collecting the baseline data was trying to understand how different types of land use, seasons, and precipitation patterns influence surface water quality in the watersheds near campus. For the purpose of this talk today, I won't be covering precipitation patterns, but if you are interested, you can read my thesis. I do go over it in there. And as a secondary goal, I look at how two different analytical instruments I use to measure the concentrations of different parameters in water, how they compare to each other, since there was a lot of overlap between the devices. Moving on to our site selection, here we have a map of the Kishwaukee River watershed. This is kind of a zoned out scale. So for those of you locally in DeKalb, to put some things into perspective, right over by sites L and NIU, we have Northern Illinois University. And then over just south of where it's USTP and Heron Creek, we have the downtown area of Sycamore. So what we're looking at in the purple shaded region is our east branch. And in the orange branch, we have, or in the orange area, we have our south branch. Each of these are Huck 10 watersheds, and cumulatively, they cover 221.8 square miles in DeKalb and Kane counties. And that, it's also part of the larger Rock River Basin, which spans from northern Illinois to southern Wisconsin. Throughout both of the watersheds runs the Kishwaukee River. This river is unique because it flows northwest. It flows northwest to join the Rock River just south of Rockford, where it then meets the Mississippi in Moline. In the watershed, the land use is predominantly agricultural, but that's expected to decrease by 14% in 2030 due to increasing amounts of industrial facilities. And the largest employers in the watershed are Northern Illinois University and industrial facilities. The past and present mining in the area is primarily for construction materials and consists of gravel, stone, and sand. So for those of you in DeKalb, I will have this map several times on my slides to put more location perspective. What we have here are a list of my sampling classifications. The sites that are marked in the yellow are sites that were classified as agricultural. They were considered agricultural if there is more than 50% of commodity crops or livestock operations within a half mile of their sampling location, or the sampling location, which was determined through Google aerial imagery. The sites that are listed in purple are the urban locations, and these sites had greater than 50% of impervious surface coverage, residential areas, or commercial business. And then there are 4 blue locations that represent rural residential land use. These were sites that had either a 50-50% coverage of commodity crops or impervious surface coverage, residential areas, or commercial businesses. But this category also contained some areas that had large urban influence despite being surrounded by commodity crops. And the best example of this is site U2. U2 is almost 100% commodity crops within the half-mile radius. However, what makes U2 rural residential is immediately adjacent to the sampling location. There's the presence of a wastewater lagoon for the town of Maple Park. Maple Park is a relatively small town, but there is still just under 1,500 residents as part of their population. So the urban influence from their waste couldn't be discredited. So what we're looking for in the water, for our agricultural influence, we're looking for nutrients, phosphorus, and nitrogen. For our urban influence, we're looking at physiochemical properties such as specific conductance. And then more as a correlation, but to try and source out our pollution or our potential contaminants, we're looking at the major ions and trace elements. But a little more specifically, for our urban areas, we're looking at specific conductance as an indicator of salts and wastewater effluent. We're looking at sodium as a source of road salt, sewage discharge, and water softeners. Our agricultural indicators, we're looking for phosphorus as an indicator of fertilizer, as well as trying to source out some potential fertilizers with their additives like manganese, sulfate, and potassium. And then in both urban and agricultural areas, there are some parameters we have to apply a spatial correlation because they are present in both types of land use. The first of these being nitrogen. For this study, or for this talk, I'm going to be focusing on nitrate today, but my thesis does cover ammonia and nitrite. And some sources of these were wastewater effluent and fertilizer. For chloride, we were looking for particularly road salt, septic tanks, and then for the agricultural influence, fertilizer. And dissolved oxygen was looked at for both areas because dissolved oxygen is a temperature, it's a temperature dependent parameter that also is influenced by salinity and nutrient input. So we were trying to identify if there were any hypoxic zones in the watershed, and if so, where and what they could be from. For sampling, samples were collected every 2 weeks over the course of 2 days. For the first day, I would travel south to north to follow what was happening in the South Branch. And on the second day, I would go from east to west to encompass what was happening in the East Branch. I started the project in January of 2021. However, there's historical data that dates all the way back to May of 2018. Of the sites, 8 were agricultural, 8 were urban, and 4 were rural residential. I also collected a blank as well. In the field, I used a Van Dorn bridge sampler to collect the samples. The Van Dorn was raised and lowered in the water 3 times to prevent cross-contamination between sampling locations. All samples that went under IC analysis were filtered using a 22 micrometer pore filter. Any sample that was not going under IC analysis went into a 1 liter Nalgene bottle, and all samples were placed in a cooler with ice packs following collection. And then here is a picture of that Van Dorn bridge sampler. Immediately upon collection, we used a Hawk probe to look at the dissolved oxygen, specific conductance, and water temperature. And this is because water temperature plays has a large influence on these parameters. And within 24 hours, we used an exact micro 20 to look at the nutrients in the water because the microbial activity plays a large influence on these parameters. Further analysis in the lab, we used ion chromatography to look at anions and cations. And the parameters listed in bold are parameters that both the IC and the exact micro 20 could detect. Even though there's overlap, part of my project was to determine if we could remove one of these devices and see if they agreed. For the lab analysis, both machines were calibrated. The IC had had 5 calibration standards and always had a check standard performed to verify the calibration. The exact micro 20 used a light stick calibration and then a check standard to verify. The pros of the IC is that there's a narrow accuracy range and high resolution, and it also follows EPA recognized methods. However, the downsides to the IC is that there's a relatively long runtime for the number of samples I had to run, and there's also some user interpretation that's needed. Additionally, there was the presence of rider ions that made bromine unable to reliably be detected. What a rider ion is, it means that there are 2 peaks that come out at the same time. Even after performing a matrix spike, we weren't able to separate out what was the rider ion and what was bromine. And then also there were high dilutions that were needed for chloride and sodium that drowned out some of the other anions and cations measured. One example of this was fluoride, which was almost consistently below the IC's calibration curve. The bright sides of the exact micro 20 is you get fairly quick results. However, the quick results come at the cost of a large accuracy range. The worst accuracy range was for nitrate, which had a plus or minus 20% accuracy range. So whatever the exact micro 20 was outputting, we knew that it was within 40%. But another pro to it is fairly user-friendly. It's relatively cheap, and it can measure a wide variety of parameters. However, it does have a low detection threshold, so dilutions are often required. And so I started the project again in January of 2021. Before 2021, dilutions weren't performed when it reached that detection threshold. So nitrate, for example, the aquatic life criteria is 44 parts per million. The detection threshold on the exact micro 20 is 30. So we can tell that the value of nitrates was above 30, but we're not able to gauge how close we are to that aquatic life threshold. Additionally, it's also EPA compliant for only a small handful of parameters. Most of these are relating to disinfection byproducts, but there also was phosphate that it was EPA compliant for. And it also measures some parameters as compounds rather than the ions. when it comes to creating a statistical correlation between the land use, precipitation, and season, I wanted to do a principal component analysis. Before you can do a principal component analysis, you have to do a Kaisermeyer-Olkin and Bartlett's test to determine whether or not there is sample variability and whether or not that variability is significant. I obtained values that were sufficient for factor analysis. Moving on to my principal component analysis, there were 3 components that controlled 52% of the water quality variability. So I did a land regression on 3 categories of land use category, precipitation variance from the 10-year average, and season. Then I looked at the marginal means of all parameters that had significance values from the linear regression below 0.05. Which leads me to our results. The first result I want to go over is some of the baseline data that was obtained. As far as nutrient concerns, I want to start out by saying that there was no statistical correlation between land use, season, precipitation, or nutrient concentrations. However, the baseline water quality data indicates that nitrogen and phosphorus are becoming contaminants of concern within the watershed. So what this graph is demonstrating is an entire watershed view of every sample that's been taken. So this stacked set of data points is one sampling day, but it's representing every site I went to. Then all the concentrations are given in milligrams per liter, or which is the same thing as parts per million. This x-axis may be a little bit different than some people are used to. We are representing, rather than using a calendar year to represent time, we're using a water year to capture the water that enters our watershed in the winter months, because it doesn't leave until that preceding calendar year. So the x-axis for these, we're looking at July, October, January, and March. And we'll see a couple of these graphs. But nitrates were found to have exceeded the aquatic life criteria standards of 44 parts per million in 15.8% of samples. Once we saw this, we really wanted to narrow down where this was occurring. So what we found is that it is over a diverse set of land uses. Just kind of starting out, the East Branch overall did fairly well in terms of nitrate concentrations. It was consistently averaging below our aquatic life criteria. But up over in the South Branch, we have several points that are averaging above or increased zones. The first of which we have up in the top left are some predominantly agricultural sites, SW1, SW2, and W. These are found over at the headwaters of the South Branch. We also have site RH, which experiences a jump. RH stands for River Heights. That is the River Heights Golf Course, just off of 88 in DeKalb. We also are seeing a pretty large spike from NIU's lagoon to the wastewater treatment plant. And while we're on the topic of wastewater treatment plants, there were 3 within our study region. We had the DeKalb wastewater treatment plant over here. We had the wastewater lagoon at U2. And we had just downstream of the Sycamore wastewater treatment plant, we would measure at M. The upstream was just north of DeKalb City, or Sycamore city limits. But at each of the sites, each of the wastewater treatment plants, we did see an exhibit of an increase in nitrates. The drop at site S1, we still have to look more into. Part of the reason for this drop, we can't isolate the problem, is because there is 4 miles between our sampling points. So we really want to narrow down what is happening in this region before we come up with a definitive reason as to what could be this drop, because it might not be as dramatic as it appears on this graph. And then the drop at site L, there's aeration immediately next to our sampling location at the NIU lagoon. So that's why we see that drop from NIU to lagoon. So then moving on to phosphorus. Phosphate was found to have exceeded the US EPA guidance of 0.45 parts per million of phosphate as phosphorus in 12.4% of samples. And once again, this was particularly a problem in the South Branch, as the East Branch was consistently measuring below our ideal threshold. The peaks are a little more subtle than we see with our nitrate concentrations. However, all three of the wastewater treatment plants within our study region and the River Heights Golf Course were found to have increased concentrations from their upstream points. As far as statistical correlations go, throughout the study period, 7% of chloride samples were found to be above the acute toxicity level of 230 parts per million. And these values were found to peak in the fall and winter with values as high as 832 parts per million. And for those of you who are math-minded, that's 3.6 times the toxicity level. When I looked at the marginal means after seeing the significance from the linear regression, I saw that our urban and rural residential areas consistently had higher amounts of chloride than seen in the agricultural land use areas. So like the nutrients, we wanted to isolate where this was occurring in our watershed. And I was able to see, once again, the East Branch is doing fairly well in terms of chloride. However, our South Branch has locations that are averaging above our threshold. And in particular, the sites S1 through BR, these are the start and the end of DeKalb city limits on our map. The next thing we wanted to do was to see if this could be due to road salt application. I tried reaching out to obtain road salt purchase data from every township in the study region, but I did run into some difficulties getting the data. So in absence of that, I made a Pearson correlation matrix to try and source out the potential sources of chloride. So I did the correlation matrix between potassium, sodium, and chloride. A perfect correlation, we would have 1.0. And the highest correlation that we had was between sodium and chloride, which was 0.904. So it's a very strong correlation, which indicates the source compound most likely is sodium chloride. Now, before I get to the next slide, there is one site in the study area that does act as a water and sediment control basin. This site is S1. So in this photo, the water is flowing toward the bottom left of our screen. What is right here is an elevated concrete slab. Oftentimes the water level is not high enough to jump this slab, so the water stays stagnant until we have a heavy rain that can push the surface of the water above. So this stops the water from flowing into DeKalb city limits. So that leads us to sodium and specific conductance. Both of these, for the baseline data, were not deemed to be parameters of concern. A lot of the specific conductance values that were above the 1500 microsiemens per centimeter, which we were trying to achieve, 50% of those were at site S1, and we believe that is due to that stagnant water just allowing the ions to accumulate. But despite periodically reaching above that healthy threshold of specific conductance, the average consistently remains below our level. So we've covered most of the linear regression, most of the parameters examined in the linear regression, but I just wanted to show you guys the table of all the parameters that were deemed to be significant. All the numbers in bold had a correlation to one of the three categories, so either season, land use, or precipitation deviation. The ones covered in green are the ones that we have discussed today. The remainder that are in bold, if you would like to learn more information, I do have them listed in my thesis. A lot of them are related to like the chemical properties. So the only one we haven't covered yet is dissolved oxygen. So when we were looking for dissolved oxygen, we were trying to make sure that there were no hypoxic zones present in our watersheds. And we were able to see that dissolved oxygen concentrations consistently remained above the threshold for hypoxia at all sampling locations. It was correlated to season, which I don't have a graph demonstrating, but this was expected because it is a temperature dependent parameter. And the correlation, there is a correlation, the marginal means, which I have at the bottom right. I was able to see that there is a correlation of higher dissolved oxygen amounts to agricultural land use than there was to the urban and rural residential areas. And going back to the main picture, dissolved oxygen can be influenced by the nutrients and the salinity of the water. So really what this is indicating is that currently salinity has the dominant control on our dissolved oxygen in the watershed rather than our nutrient inputs. So as my secondary goal, I wanted to create that statistical analysis between the IC and the exact micro 20 to see which one, or to see whether or not these methods agreed. So I did a bland Altman analysis, which is a statistical test to determine the effectiveness of a new method, which in our case would be the exact micro 20, relative to an already established method, which would be our IC. And what I found was that the IC and the exact micro 20 had low agreement on nearly every parameter examined. And we have a hypothesis for 2 reasons as to why. So the first hypothesis is that it's due to having no dilutions prior to 2021. So using an example, I thought nitrate was the best way to demonstrate this. So this first graph on the left, what we're looking at is the mean plotted over the difference. And then we have 95% confidence intervals placed relative to the bias of the established method. If the 2 technologies agree, most of these data points we would want to see within these 95% confidence intervals, but we're not getting that with our graph or with our data. So what I did then to further tease out why is I plotted the concentrations between the IC and the exact micro 20. And I was able to see this nearly horizontal line that appears. And this is where the exact micro 20 data couldn't reliably detect concentrations. This is where we had listed greater than 30. And since all we know is it's greater than 30, we don't have a range of what it could be. It has to stay at this point. We currently don't have enough data to perform this analysis without having dilutions done. So that's another avenue we may explore. And then the second hypothesis is that the IC measures ions, whereas the exact micro 20 measures compounds. So here I have an example of calcium. The agreement is better, but we can still see the majority of our points are without or outside of this 95% confidence interval. And we really need it to be within for those to have agreement. So now using calcium, so the exact micro 20 is measuring calcium carbonate. However, that means it's disregarding any other compound that calcium may be bound to. So for example, farmers use calcium sulfate or gypsum as a fertilizer additive. So we're not getting any of the calcium measures that are coming from the gypsum or even natural sources of gypsum. So we're really not getting the full picture because they're not measuring the same analyte. So to conclude, from an overall perspective, our watersheds are doing fairly well. That being said, there are some emerging concerns that we should keep an eye out on. So the South Branch does have emerging nutrient concerns. There is no evidence of hypoxic zones or harmful algal blooms. However, the nutrient concentrations do support their growth. Of the South Branch, the headwaters should be the highest concern for the nutrient concentrations. The overall dominant land use influence was found to be urban and rural residential. This is through high chloride and specific conductance values that were suspected to be from road salt application. Our suspicion was supported by the Pearson correlation matrix. And although acute toxicity levels for chloride are occasionally reached, it's not an immediate concern, but should be taken into consideration when planning for winter road weather. And this is especially true for sites that are within DeKalb city limits. And when it comes between the IC or the exact micro 20, we should be utilizing the IC when possible over the exact micro 20. This is because the exact micro 20 has large accuracy ranges that are introducing unnecessary error. And it also measures compounds that create data that are not fully accurate. So unless we're measuring for that specific compound, we shouldn't be using it to interpret ion data because we're not getting that full picture. And so after this work, some future steps we could take. In terms of agricultural land use and the nutrient concentrations, we should be prioritizing the headwaters of the South Branch when we're trying to think of cost share, conservative farming practices, as well as community outreach. In our urban areas, we should be implementing nutrient reduction strategies such as bioswales in the ravines near the DeKalb wastewater treatment plant and the River Heights golf course. For our high chloride concentrations, we can start looking into road salt alternatives or maybe using a combination for the winter weather in the South Branch. So an example of this is we don't have to completely get rid of chloride, but maybe introducing a sand additive to help gain traction while reducing that chloride input. And although our East Branch is doing fairly well for chloride and nutrients, we should still be monitoring it to stay on top of the data and making sure that they are within ideal thresholds. And I would like to thank the DeKalb Community Foundations and DeKalb County Watersheds for financially supporting this project. And they have also provided me with so many comments and feedbacks as the project has developed. I'd like to thank my advisor, Dr. Melissa Lincheski, for all the resources she's provided me with and all of her guidance throughout my time, both my undergrad and my graduate degree at NIU. I'd like to thank my thesis committee, Dr. Chit Whitty-Yu and Dr. Megan Brown, for providing me with so much support and guidance as I've worked through my thesis. I'd also like to thank Erin Yu and Ian Halterman for helping me with sample collection and sample analysis. And thank you.
Yay, so congratulations. And very pertinent for today. I mean, we're going to have a major snowstorm here on Thursday and Friday. So talking about road salt, we're going to be seeing some of that input coming in this week. So I thought that was really pertinent for today. With that, I'd like to open up for any questions from any of the guests who are here, and then we'll go into a closed session with just the committee. So if there's any questions, please raise your hand or put it into the chat. Oh, come on. Somebody's got to have a question. There you go. There's a question for you in the chat. It was about, do you think beet juice could be a good alternative to road salt?
There have been studies in some areas that have shown beet juice does work as like a road deicer, but with the increased nutrient concentrations in the South Branch, I wouldn't recommend adding it because the beet juice can introduce unnecessary nutrients when it runs off. So really to keep the nutrients under control, I think the sand additive would be a better option.
Excellent. Okay. Other questions? Okay, I'm not hearing any, so we'll give you another thank you. So, okay, so Ashley, if you can stop recording. We will ask everybody who is not part of the thesis committee to please leave the room. And if you do think of a question later on, feel free to email Ashley and then we will reconvene in about 5 minutes, the committee. So we'll see you all